Thanks for the opportunity to speak at this conference. My name is Ryan Abernathey, and I'm a physical oceanographer at Columbia University. And I'm really excited to share the concept of OpenOceanCloud, an idea that I've been developing over the past few years in collaboration with Chelle Gentemann of the Farallon Institute. So this talk is going to define a problem that I think a lot of us at this conference recognize, which is that ocean data are huge and complex. And this really limits scientific inquiry and restricts participation in oceanography. I'm going to propose a very general solution that we're calling OpenOceanCloud, which is a new approach to infrastructure based on cloud computing, open data, and open source software. And I'm going to try to convince everyone here who is thinking about building infrastructure for ocean data to use some of these concepts and principles in whatever you're building. So just to introduce the problem, here's a fantastic video from NASA showing many interrelated components of the coupled Earth system. This video includes data from satellites, which observe ocean properties such as ocean color, temperature, and also simulations, which are really important for synthesizing these observations and making predictions and projections about the Earth system. And each of those different data streams can produce a huge amount of data. This is a projection from NASA about how much data they are going to be storing in their data archives, their Earth science data archives over the next decade. And those numbers on the y-axis are hundreds of petabytes of data. So there's a huge amount of richness and scientific opportunity waiting to be exploited in this data, but the scale and the complexity of the data is a huge infrastructural challenge. And it's not just satellites and models that produce large and complex data sets. In oceanography, we have an increasing range of autonomous measurements of the ocean, such as this visualization of the Argo floats, which are providing tons of important and useful information, but are equally challenging to access and process. So the typical experience when someone wants to work with ocean data is that they go and try to download it onto their computer. That's kind of the standard workflow. But of course, when we are measuring our data size in petabytes, that workflow really doesn't work. The other thing that tends to happen today is that privileged institutions create data fortresses. This is a cool term that was coined by Chelle. And let me explain what I mean. So I work at a rich Ivy League US university, Columbia University. And we want to do cutting edge ocean research. We want to bring data from all these different data providers into our environment. So we have a big supercomputer in our basement. We download that data, and we can do a lot of great research with this infrastructure. But the problem is that this way of doing research creates a lot of challenges to inclusion and collaboration. In order to reproduce any of our results, you need to either have your own data fortress or get inside our data fortress. So that's a real barrier to collaboration. Furthermore, many other institutions are doing the exact same thing, storing the exact same data. So it's really inefficient and duplicative. And finally, it really can't scale to our future data needs, because while we may be able to store 100 terabytes of data this way, we can't store 100 petabytes. So this concept of a data fortress is really limiting to inclusion and knowledge transfer in oceanography. An alternative way of working has been pioneered by the Pangeo project. So Pangeo is a grassroots collaboration between scientists, software developers around open source tools for solving real problems. We've received support from the NSF EarthCube program and many other funders, including NASA, and we've grown to include many partners in industry and research around the world. So Pangeo builds with open development. We start from scientific users and use cases and really identify what are the bugs, the bottlenecks, the limitations that are preventing them from doing their science. Then we do open source development in a wide range of community-driven software libraries, mostly in the scientific Python area. And we also deploy infrastructure on high-performance computing and cloud environments, where the software tools and the scientists and the data can all come together to perform end-to-end workflows. This approach is really platform agnostic. This way of working can be deployed on a traditional supercomputer or also in any of the cloud providers. This experience with Pangeo has led us to propose a very specific sort of architecture to power this idea of OpenOceanCloud. And it's based on the three pillars of cloud-native scientific computing. The first is access to analysis-ready, cloud-optimized data, cleaned, curated, open-access data sets that are available from a high-performance storage system. We bring that together with data-proximate computing, which allows us to bring analysis to the data rather than downloading data, using any open source data science language such as Python, Julia, or R. We combine this with elastic scaling, which allows the compute resources to scale up and down on demand in response to the user's needs. This is one of the great advantages of working in a cloud-like environment. On top of this basic foundation, we can provide expert analysis via Jupyter notebooks, front ends and dashboards through API access, and connect to downstream third-party services and applications. This architecture was recently described in our paper, Cloud Native Repositories for Big Scientific Data, and it can be deployed on any standard generic cloud platform. The great thing about this type of model is it's federated and it's extensible. That means any institution can add capacity to OpenOceanCloud, either by adding their own entries to their own data library or providing more computing. And this allows us to grow OpenOceanCloud in an organic way. So our vision for OpenOceanCloud, instead of a data fortress, is a data watering hole. By bringing a lot of great ocean data into the cloud and coupling it with this type of infrastructure, we can bring many different researchers and stakeholders together into a common working environment, creating new connections between research, education, and industry. And just as one example of the impact, we can have a Pangeo-style environment was recently used in the Ghana Coastal Ocean Environment Summer School to provide data and computing access to those summer school participants. Working this way will allow us to do faster science, make more discoveries, increase reproducibility and global collaboration, and unleash the creativity of scientists across the world. The OpenOceanCloud concept has evolved considerably. This idea was first presented at the UN Ocean Decade launch 1 year ago in February 2021. In September of 2021, we undertook a collaborative white paper brainstorming activity as part of the UN Ocean Decade laboratories. And in spring 2022, so very soon, we anticipate publishing a white paper giving detailed description of the OpenOceanCloud platform vision we have. 2023 is the NASA Year of Open Science, and we hope to use that to really push forward the OpenOceanCloud concept. Our forthcoming white paper will contain contributions from over 50 authors from 6 different continents. It'll address the following themes: the co-development of OpenOceanCloud technology and infrastructure, how can OpenOceanCloud engage, organize, and empower a diverse community of participants, and how can OpenOceanCloud support and amplify other UN Ocean Decade activities. So we're really excited to share this with the community. If you want to learn more about OpenOceanCloud and engage with the project, here are some links that you can go to. We're particularly interested in how other infrastructure builders at this conference can leverage the concepts of open data, open source software, and open infrastructure to build the ocean research platform of the future. So I really look forward to reaching out and discussing with everyone at this conference.